real word. Making sure we understand this. Number 1. Brendan, what type is that right there? Lemison. Alright, Jordan, is a lemison with a dimple or inner loop? Inner loop. Okay? So we need to make a chart. If I plug 0 in here, cosine of 0 is 1. 1 times negative 4 is negative 4. Negative 4 and 1 gives me a negative 3. Cosine of pi over 2 is 0. That goes away. That leaves me 1. Cosine of pi is negative 1. Negative 1 times negative 4 is 4. Plus 1 is 5. Cosine of 3 pi over 2 is 0. That will give me 1. Cosine of 2 pi is 1. That gives me negative 3. Negative 3, 0. I find 0. Go opposite direction. And there's my lemison. Big T, what type is this right here? Cardioid would have a plus or minus in there, buddy. There's no plus and minus, so it's either circle, rose, or lemison. Guys, that's what I'm telling you. Don't take this test for granted. You have got to go home and learn these. This is the easy part of the test. What we cover the next 3 days will be the hardest thing you do. That is a rose. The reason it's a rose is you have a number greater than 1 in front of theta. Okay? So, the 2. How many petals will I have here, Caitlin? 4. So I'm going to have 4 petals. Alright. Daniel, how many equations do I set up for this? 1 or 2? 2. It's even. If this number is even, you're going to set it equal to positive 1 and negative 1. The argument. This is the argument. Okay, we're not going to put a 3 there. We're going to say sine of 2 theta equals 1. Okay. Sean, what value of sine gives you 1? Pi over 2. And I put plus 2 pi in. Now I'm going to divide everything by 2. When I divide that by 2 there, guys, that gives me pi over 4. These 2's cancel out. I let n be 0. That will be pi over 4. I let n be 1. That will give me 5 pi over 4. Now I'm going to do sine of 2 theta equals negative 1. Alright. 2 theta equals. Where does sine give me a value of negative 1 at, Jake? What is it? 3 pi over 2. Very good. I'm going to divide everything by 2. Theta equals 3 pi over 4 plus pi n. Let n be 0, so that's going to be 3 pi over 4. Let it be 1, that's going to be 7 pi over 4. I have 4 petals, I should have 2 here and 2 here. Now, this number right here tells me what ring to go out to. 3. I always have a point at the pole. So I'm going to go pi over 4, 1, 2, 3. 5 pi over 4, 1, 2, 3. 3 pi over 4, 1, 2, 3. And there's my flower, my rose. Number 3, Taylor, what type is this right here? Circle. I know it's a circle because you got to understood 1 right there. It is sine. So would that deal, Reese, would that deal with my horizontal or vertical? So I go to 0 for a circle. There's always a point there. And I'm going to go down 4. 1, 2, 3, 4. And draw a circle. Number 4. Kira, what type is this, hon? Cardioid. Very good. It's a plus, and both of the absolute value A and B is the same. So on this one, I need to make a what, Zach Moon? chart. Yep. If I plug 0 in, cosine of 0 is 1. 2 times 1 is 2, plus 2 is 4. Cosine of pi over 2 is 0. 0 plus 2 is 2. Cosine of pi is negative 1. That's going to give me 0. Cosine of 3 pi over 2 is 0. It gives me plus 2, and back at 4. So 0, 4. And there's my cardioid. Last one, this is r squared. This is a lambiscent. What you do, since it's got cosine, put a dot at the pole, you put a dot at the pole regardless if it's cosine or sine. But if it's cosine, that means it's going to be on the horizontal. You take the absolute value of 9, which is 3, and you go 3 in left and right direction, and you make looks like a bow tie.
Did you mean square root of 9?
Square root of 9, yep.
Square root of 9.
Okay, let's continue. Review and turn to your homework. You have problems 33 through 38. Thank you. All right, on number 33, how many petals will I have on this one, Ms. Sherman? Yes, how many petals will I have? 3, very good. How many equations will I set that to, Jessica? 1. So watch this. We're going to have cosine of 3 theta equals 1. What value of cosine gives you a value of 1? Gracie? 0. So I'm going to have 3 theta equals 0 plus 2 pi n. I'm going to divide everything by 3. Theta equals 0 plus 2 pi over 3n. I let this be 0, so one of my answers is 0. If I'm going to have 3 petals, how many answers would I have down here at my equation? 3, so I got 0. I plug 1 in, I get 2 pi over 3. I plug 2 in, I get 4 pi over 3. Alright, so now I'm going to graph all 3 of these. Go out to the third ring. Oh, I meant to go out to the first one. Very good. I'm sorry, because there's a 1. Sorry about that. You have a little flower. I was looking at number 34. We're going to go out to what ring on that one? 3. Ring 3. How many petals? 4 petals. Alright, I'm going to set this equation, the argument, to equal to 1 and what? Negative 1. So sine of 2 theta equals 1. Sine of 2 theta equals negative 1. What sine value gives you a value of 1, guys? Pi over 2. Divided by 2, that's going to give me pi over 4 plus pi over n. I got 4 petals, so I'm going to have 2 answers come from this one, 2 over here. So theta equals, I let n be 0, gives me pi over 4. Let it be 1, that's going to be 5 pi over 4. What sine value gives you negative 1? That is 3 pi over 2. I'm running out of room here. That's going to be 3 pi over 4 plus pi n. I let n be 0. That's going to be 3 pi over 4. Let it be 1. That's going to be 7 pi over 4. Did we not just do this one? Oh, we did that one a while ago. We don't have to do that again. And graph it. We did that at the beginning examples. All right, let's go down here to the lambiscents. These are lambiscents because you see r squared. That's the only ones that will be r squared. Okay, this is sine. When it is sine, you go to the pi over 4 degree. Take the square root of 16. What is that? 4. You put a dot at the pole and go in quad 1 and quad 3. And that is your graph of that. This is cosine. It's going to be on the horizontal. What's the square root of 25? 1, 2, 3, 4, 5 in both directions. And that's your graph. You always take the absolute value of the number in front of this. That's understood 1. Absolute value 1 is 1. On sine, you go to pi over 4. In quad 1 and quad 3. Mm-hmm. 38. You said, Mr. Shush, I don't know the square root of 2. You want to get a decimal. Square root of 2? 1.4, okay? And there's my graph. Are there any questions on lamices? Now, do you feel better after the review this morning? You've got to review that on your own throughout the week, okay? Next, what we're going to do, because this is how your quiz is going to be set up on Wednesday on this. It's going to be matching equations with the graph. So we're about to do a worksheet together to make sure we understand how we pick the graph. Chris, did you finish that? Erase your name off the board, please. Alright, what we're going to do right now, guys, when you have a worksheet like this, what I like to do first is go through and look at my equations, and I find my roses first, okay? I pick a category and I go through here. Let's look at our 1 through 14. Which one are roses? Just name the number. Number 1 is a rose. What's another rose? 9. Number 9 is not a rose. That's a lamicent because you got R squared. Which one? 6 is a rose. What's another one? 10 is a rose. Do you have any more? 12. Very good. Now let's look at those 4. On number 1, how many rose petals will I have? I will have 3. On number 6, I will have how many? 3. Say how many rose petals I'm going to have, guys? 3, okay. Number 10, how many will I have? 4. Okay, look at the graph on all your choices. Which graph has 4 rose petals? J. So mark that one off. So you said number 10 is J. So I'm going to mark that one off. Okay, number 12. How many rose petals will it have? 8. So that's going to be what? Mark that one off. Alright, so we're down to K and L for 1 and 6. Okay, so you're going to do a little work on that one. No, you really don't. Okay. What ring does this one go out to, guys? 2. Which one will go out to? What does it look like K is going out to? 2, and L looks like it's going out to what? Look at that bottom petal right there. It's 3. So number 1 would be what? K. And number 6 would be what? L. Because I'm going down to 3 right here. I know these graphs are kind of weird, but you eliminate choices right there.
Why are they graphed on like regular graphs?
I don't know. For some reason, it's crazy like that. Alright. Now, let's go find our lamicents first. They are easy. Which ones are my lamicents? 3 and 9. Which one would be 3, guys? Looking at your choices up there. M. Which one would be 9? D. Okay. Let's go to our circles next. Remember, circles always has a point at the what? pole. So of your graphs up here, which ones are circles? B and F. You said, Mr. H, look at G. G is not a circle. You can't see the dimple in that lambison, but a circle always has a point at the pole. It doesn't have a point there. E doesn't have a point at the pole. So your only circles are B and C. All right, so let's locate our circles. 4 and 13. What now?
C isn't a circle.
B and F.
I said B and F. Oh, I said, sorry, B and F. B and F are circles. All right, so number 4, 3 sine theta. Which one would that be? B, because sine is on your vertical and it goes up to 3. 13, 4 cosine theta. That would be on your horizontal going out to 4. That's F. So mark those off. All right, let's locate our lambisons with, okay, let's look at our graphs up here. We only have one lambison with an inner loop, don't we? Which one is that? What graph up here? Oh, H? Oh, you got 2. H and N, okay. Let's look see if we got a cardioid. How many cardioids do we have? 1. This one right here, isn't it? That's the only one that has a dimple at the pole, isn't it? So let's find the one that has a cardioid. Which one is that? 7. So we mark that out. Alright. So now we got H and N. One with the inner loop. Which one of these left down here would have an inner loop? 2 and what? Hey, do you both see that the A is less than that? Okay, now let's look at this. This has a cosine in it. Cosine will be around which one? The horizontal or vertical? So isn't this one around the horizontal? So that would be H. This one is all about the vertical, isn't it? So that would be N. Do you see how to eliminate your choices? You probably like this better than graphing them, don't you?
Oh, yeah.
Alright, now the last 3 we'll have to do some work. You have to make tables to see what's going on. So let's start with number 5. And you don't have to do every one of these points. You can just start some because you start saying, if I plug 0 in, what's sine of 0? What's sine of 0? Sine of 0? 0 plus 5 is 5. Sine of pi over 2 is what? 1 times 2 is 2 plus 5 is 7. Sine of pi is 0 plus, that gives me 5. So let's start looking here. If you look at E right here, guys, you see this pi over 2 up to 7? Pi over 2 is up here, isn't it? Where does that go up to? 7. So would that be your answer? Yep. Now we're down to the last 2. I'm going to look at number 11 here. If I plug 0 in, cosine of 0 is 0. 0 and 3 gives you 3. Cosine of pi over 2 is 1. 1 times negative 2 is negative 2, and 3 gives me 1. Cosine of pi is negative 1. That's going to give me 5. I look at 0 to 3. Did I do that one right? No, I didn't do that right. Cosine of 0 is what? 1. That should be 1. Cosine of pi over 2 is what? That should be 3, shouldn't it? Did I do it right now? Okay. That should be 103 pi over 2. I'm sorry. Alright. Which of the graphs go out to 0, 1? G or I? I. That would be I, and the last one would be G. So that's how your quiz will be set up on Wednesday. Are there any questions on that activity?
Wait, so our quiz is going to be just like this on Wednesday?
Not the same problems, but the same format.
No, like,
Yeah. Are there any questions? Alright. Zach, can you help me? For your homework, you need your textbook every day this week because you're going to have problems out of your textbook for homework. I'm going to go and give you one of these because you're going to need something to graph some problems with tonight. So here's some court paper. Reese, can you help me? I was going to make you copy all your notes off the board, but I'll handwrite them for you. This needs to go behind your notes that we're about to do now. Alright, while they're passing this out, here's your notes. We're going to start learning what's the polar form for complex numbers. Somebody remind me what a complex number is. It has a imaginary part and a what in it? A real part. It has an I to let you know it's imaginary. So in this section, we represent complex numbers in polar form. Pray if you didn't have to do this, dual enrollment, you go deeper in this. In this section, we represent complex numbers in polar form. This enables us to find the nth roots of complex numbers. To describe the polar form of complex numbers, we must first learn to work with complex numbers graphically. Now, we're going to teach you how to graph complex numbers. Now, you learned back in middle school how to graph real numbers. To graph real numbers, if I had a set of real numbers, -2, 0, 3, 5, you would just simply draw a number line and put a point on them. Do you remember that? Well, now, complex numbers are not that easy. Complex numbers have two components, a real part and an imaginary part. Since they have a real and imaginary part, we work in the complex plane. We need two axes to graph complex numbers, one for real part and one for imaginary part. Two axes, real and imaginary. So let's look at an example of one. Look at this complex plane right here. It looks sort of like a X and Y axis, but it's not. This is the real axis, is on the traditional, that looks like the traditional horizontal. The imaginary part is on the vertical part. You label it 1, 2, 3, 4, 5, and back this way would be -1, -2, -3, and so forth. Your imaginary, 1i, 2i, 3i, 4i, 5i. You said, Mr. Fisher, what if I had 1.3i? You go above the 1 a little bit. Do you see how that works? Here, -1i, -2i, -3i, -4i, -5i, and so forth. Does that make sense? So if I wanted to graph 1 plus I, go 1 up positive 1i. If it had been 1 negative I, it would have been 1 negative I. Does that make sense? 2 plus 3i, just like if you were graphing the point 2, 3. 2 plus 3i, and that's how you label, you put the expression. 4 minus 2i, go over 4, down 2i. That is how you graph complex numbers. Does that make sense? Are you sure? Now, the modulus, that is the fancy word for the absolute value. We don't say absolute value of a complex number. If I say find the modulus, that is the absolute value of a complex number. The modulus. Say modulus. Okay? The modulus of the complex number of, let's say this is your complex number. The number is a plus bi. This is the symbol for modulus. Is the absolute value z is equal to the square root of a squared plus b squared. I feel like we've had that formula so many times this year. But the modulus is the square root of a squared plus b squared. This squared plus this squared, and take the square root. So today, our learning targets, first one is our graph polar equations. Do you feel better? What we reviewed at the beginning. I need a hand signal. Okay. Now, the only thing we're doing today is we're going to learn to graph and find the absolute value. That's all we're doing today, okay? So turn to the second page. It says graph each complex number and find its modulus. Now, I don't expect you to draw a graph, each one of these. Do you see I came over here and drew one big graph and just labeled it? That's what I expect you to do, okay? So let's do that right now. Let's go to the side over here. Alright, so we want to graph 2i. Okay, if we were graphing 2i, you always graph your real part first. Do I have a real part? So I would stay at 0. 2i, will I go up 2 or down 2? Up 2, and that is my point for 2i. 2i is at this point right here. Just as if I was graphing 0, 2. Okay, does everybody see that? Alright, now we need to find the absolute value of this. Absolute value of z equals the square root of a squared plus b squared. Now guys, your a is your real part. What's my real part here? I don't have one, so I will put 0 in for that variable. My b term is 2. Gives me 4, so my absolute value of that complex number is 2. So there's my absolute value, there's my point. So in the formula, z equals square root of a squared plus b squared. A is your real part, b is your imaginary part. Alright, let's look at 2. 4 plus I. Graph the real part first, so I'm going right or left 4? Right 4, up how many? And I'm going to label it 4 plus I. I went right 4, up 1. Now let's find the absolute value. Absolute value of z equals the square root of, what goes in for a? 4. What will go in for b? 1. 4 squared is 16, plus 1 squared is 1. Can I break 17 down? No, that is your absolute value. Mr. Josh, I thought you said this was going to be hard. This is easy today. So use tonight to review. Number 3, 8 minus 5i. I graphed the real part first, so I'm going right or left 8. Right 8. Oop, I didn't draw one over. I'm going to put 8 right here. I'm going to go right 8 and then down how many? And I'm going to label it 8 minus 5i. Absolute value z equals the square root of 8 squared plus negative 5 squared. I get 64 plus 25. That gives me the square root of 89. That's the absolute value of that complex number. Alright, number 4. I graph my real part first. What's my real part here? So I go right 3. Do I have an imaginary part? No, I just stay right there. That is 3. What's my a value here? 3. My b value is? So that's going to end up giving me square root of 9, which is 3. Alright, number 5. I'm going to graph my real part first. What's square root of 2? What's the estimate for that?
1.4.
So you're going to go right 1.4 and then up or down 3. You just estimate. It doesn't be label it square root of 2 plus 3i. It's amazing how many coordinate planes. We learned the traditional this year. What's another coordinate plane we learned? The 3D coordinate plane. What's another one? Polar, and now the complex. There's 4 coordinate planes you've learned this year. Alright. Absolute value of z equals, what's my a value? Square root of 2. What's my b value? When I square the square root of 2, what would that be? 2 plus 9, which is square root of 11. That's the absolute value of that problem. One more. Number 6. What's my real part there? Negative 4. So I'm going to go left negative 4. Now I want you to take your calculator right now and say square root of 3 divided by 3. This is our last example. What is it? 0.6. Thank you. It's negative 0.6, so I'm going to go down right there. So I'll graph that. And this is what I'm even going to do on your test on Thursday or Friday is you just draw one graph. You don't have to draw a graph every time and just label it. Now let's do this. Absolute value of z equals negative 4 squared minus negative square root of 3 over 3 squared. What's negative 4 squared? 16. Now let's be careful. I want to really go over this. First of all, when that's supposed to be a plus in between them. I'm sorry. When I square this right here, what happens? First of all, negative times a negative is a what? Okay. What happens to the square root here? It goes away, so I'm left with what? Yes. What would that give you? 3. On bottom, what's 3 squared? So it's 3/9, which reduced to 1/3. Alright, when you add that, guys, they want you to, let's leave it as 49 over 3. Because you get, that's your improper. And the reason why I do that is, can't you do the square root of 49? Yes. He said, Mr. What if I just did a decimal? If you did a decimal, I'll be fine with it. But square root of 49 is what? 7 over square root of 3. I took the square root. Well, you can have a square, so I'm going to rationalize. So that's going to be 7 square root of 3 over 3. That's my absolute value. I'd rather you leave it like this because this is a more precise answer. Square root of 49 is 7. 7 over this, that's my absolute value. Okay, so 2 things we learned today. We learned how to graph a complex number in a complex plane. I need an answer. Good on that? You understand how to find the absolute value of complex numbers? Okay. Tomorrow we're going to start transferring them to polar form. Your homework's over there. The first page is just some matching graphs. You match the ones with the equation and practice graphing. And the second page is this as a review. I will do a homework check tomorrow. And actually, you're going to turn page 600 into me. So do that on 2 separate pieces of paper. Page 600 will be turned into me to be graded. 610 we will go over.